Um, I'm Pablo Prieto. I'm a PhD student at the Comparative Bioinformatics Lab at the Center for Genomic Regulation in Barcelona. And so I was going to say something that I'm very happy to be here these days. This is my first time in Sweden, and it's really nice to be around cold ice and a lot of snow compared to what I'm used to be, like more or less right here in front of the beach. But anyway, so this is my colleague in the lab, Pablo. He's the lead developer of Nextflow, but unfortunately he wasn't able to come here to the workshop. And I think he's more or less now around here, around Brazil. So I expect that he's enjoying these really nice places like Rio de Janeiro, and he's not getting too close to these kind of places like favelas, which will mean that we will have maybe an open position soon. And Nextflow will be really sad about it. So what is Nextflow? So as you have heard already, there are many of these toolkits or frameworks meant for these parallel and reproducible computational pipelines. And this is something that was developed in our lab in order to cope with these genomics and transcriptomics and sequence analysis based projects that we are working on. And basically for the bioinformaticians, they have to cope with a lot of this data, but they applying several methods and scripts and tools that they have already used. And what they end up using is kind of some of them spent well, saying that they spend a lot of time building these pipelines in order to kind of be able to save some time in order to keep analyzing their further results. And Nextflow was meant to, the development of Nextflow started to cope with this kind of problems. And the project rationale behind Nextflow is that the aim is to provide this kind of features. First of all, we wanted something that it will provide the fast prototyping, because as we have seen with many collaborations, many bioinformaticians, people, they don't want to spend so much time building this kind of pipelines. They have sometimes too much troubles because they already say that they have the tools and the methods, and they have already done separated analysis. So what they want is something that allows to them to do this kind of composition and more or less nothing else, without having to spend so much time and directly get the kind of automatization. But it's not always as easy as people want. So another aim for the development of Nextflow is to be able to reuse any kind of existing script or tools or any kind of software, and high-level parallelization model. So we wanted that these datasets in genomics and so on can be quite big and they can be split quite easily. We want a kind of an abstraction layer that helps you to do this parallelization for you. And a really important feature that we have been working on is that we want it to really be portable across many platforms, because usually, so we are working on production environments, on testing, on development. Also, we are working in with different clusters. Also, we have set up different web servers around, and sometimes the software that is installed it's not exactly the same, and you end up sometimes having problems with the system administrators. And maybe here they are better. I don't know from what framework. Not always. And also another feature is that it has to enable reproducible pipelines, which it can be quite problematic, as people have mentioned already. And lightweight and easy to install. So since we have all these issues with the software and dependencies, we want something that is kind of minimal, and it doesn't need any other requirement or installation or extra configuration in order to run. And it doesn't have to be a problem for the performance of the system as well. And so how does it work? So mainly when you develop a pipeline within Nextflow, what you end up defining is kind of a flow with this declarative manner that I will show to you. This is kind of following this data flow programming paradigm. And what you are really using within these pipelines is defining these processes which compose your pipelines. And each of the processes encapsulate a set of inputs and outputs and a script or pieces of code that you can execute. These pieces of code can be either Java or Ruby, because as BPAP it's built upon Java and Ruby, so you can execute directly this kind of native code, or you can also input command lines, call your scripts, or even if you change the shebang here in this script part, you can also put Python or Perl code or whatever is your language that you prefer. And so the good thing is that you end up having this task dependency parallelization just automatically more or less defined implicitly by these input and output declarations. So there is these elements, the other main elements from the pipeline, that are the channels, which are the elements. It's kind of asynchronous queues that are used in order to communicate between all these processes within the pipeline. And this is what it really defines the dependency graph and how it's going to run and trigger the task generation for each of the processes. So how does it work? So this is a simple diagram. Here you can see these two main elements. The channel, as I have said, is kind of a synchronous queue, and the process. So here what we define is that for this process, we define this channel as an input, and at some point the channel is going to receive this data Z, Y, and X, and it will dispatch all these tasks. It will generate these three tasks when one receives all these pieces of the data automatically. And so this is one kind of typical example that you can apply in our pipelines, where you have big data sets that you can split either by samples or by sequences or families or chromosomes or whatsoever. So you have this kind of operators that are the kind of it's not like functions, but it's something that you can apply to the data that is passing through these channels in order to transform it. And then this is going to go to all these processes, and it will automatically trigger for each of these pieces that you have split the execution, and it will go downstream, triggering all the processes of execution. And in the end, you can have all these filtering steps or collecting steps in order to merge and get your final results. And so what does a script looks like in Nextflow? It's a simple, I think, as this. So here you can see that there are two main elements. This is a channel that you define here with this function. You create a channel from this path that is just a FASTA file. And here what you are doing is to split this file in sequences, and it goes directly to this channel that is declared here as an input. So for each of this channel sec, each time it receives one of these pieces, it will create this file for this process, and it will trigger this execution. So as you can see here, you declare as well the output that you are redirecting into another channel. So these are always that you declare something here in inputs and outputs are the channels, which are as I have said, the elements that are used to do the communication between the processes. And here you have this script directive, which is used to call command lines, or you can put your scripts, or if you change this script tag by exec, you can execute Java or Ruby code, or even here, as I have said, you can change the shebang, and you can easily put the Python code or whatever you prefer. So it's as easy to run as I'm showing here. So it's Nextflow run in your script, and it will initially show some of the traces of the execution. And if you have it, as in the previous example, if you have defined that the output is going to be redirected to the standard output, it will show it here. And of course, you have more command line options available. Like the resume command line option, in order to kind of be able to resume the execution of your pipeline upon, let's say, a crash, or because you wanted to stop your pipeline somehow, or it just finished. So, and this is this automatic checkpoint feature, and that it's transparent to the user, and that allows you to resume your execution. This is something that you can as well disable, because as you can imagine, what it's going to do is kind of keep a cache containing all the intermediate results and all the scripts that have been run, in order to, in case that you want to resume the execution, it will check whether if you have modified something in the pipeline, if the intermediate results that you have in this cache directory, it matches what it's supposed to generate the framework. And I think this is really good for testing and development, because it means that you can start working on your pipeline, you can develop your code there, and you can already start to analyze your data, and if it's not finished. And then afterwards, maybe you want to continue developing, and you can just use the resume option, and you can just continue from where you stopped. And also, it's good for fixing errors. Another feature that we have been working in is reproducibility, because now that is very important. If you publish something, it's very important that if somebody wants to reproduce your results and wants to get your code, it's able to reproduce it in the same way. And sometimes this can be quite tricky, because there are many elements involved. So it's maybe modules, different version softwares, environment variables, different configurations. So what we try to do is that to be able to that your scripts can run on multiple platforms. It doesn't matter kind of the platform on where you want to run your scripts. And this is because a pipeline in Nextflow is supposed to be self-contained. So it's supposed to contain the script for Nextflow, but it's also supposed to contain, if you are using any library or any binary, it's supposed to be in in your project directory, and this should be shipped as well with the scripts and with your configuration, that it's lying apart from the Nextflow pipeline. But you still can have these binary dependency problems, and in order to solve this, what we have tried is to use Docker, which is something it's relatively new, and it works quite well, and it's kind of a virtualization technology. But for this, at least you don't need to virtualize the hardware in a situation. And this is shipped also along with Nextflow, and Nextflow is able to kind of build the Docker containers upon a kind of a Docker container description as well. And so Nextflow is supposed to be platform agnostic, so because it runs on Ruby and on Java, which is supposed to be platform agnostic, supposed to. And it can run either in your local machine or in your laptop, or you can set up different executors, and you can maybe run it in your Sandwich engine or any other platform that you have in your institute. So the supported platforms that we have tried until now, it's a Grid Engine, Univa, that we are currently using in one of the clusters, Slarm, Torque, PBS, LSF, and DNA Nexus. And also now we are trying to use this kind of in-memory computing grid, and we are testing on Amazon Cloud. It's not working that well, but at least we can try to, in some cases, for some not so big projects, kind of deploy grids and run the Nextflow pipelines in Amazon Cloud. And so another feature for reproducibility is Git integration. So now within Nextflow, you can kind of handle and track changes in Acting System Manager. You can plug in your repository either in GitHub or Bitbucket or something like that, and that is going to simplify the sharing of your pipeline project, of course, because when you are going to publish your pipeline, as I think many journals now accept that you provide a DOI that references the exact version of your pipeline that you have used for your analysis. And since in Nextflow your pipeline project is supposed to be self-contained and using also Docker, it shouldn't be a problem to reproduce your results, even the data. And it's also quite useful to compare results of different versions and revisions, because something that within Nextflow you can change from one version to another and compare the difference in the results and in the code. And so just to show you how easy it is, here this is one repository in GitHub for the lab. So this is a pipeline from Nextflow, and so if you just have installed Nextflow, you can just call to run this repository and this pipeline, and Nextflow will automatically fetch this repository and run it for you. Of course, it will fetch a copy into a local folder. And so in conclusion, to wrap up, Nextflow allows you to write a pipeline by reusing your existing tools and scripts. So I think it's something that more or less many people, many informaticians are happy, at least in our institute, with it and are able to use it. And the parallelization is managed automatically by the framework, and for us, we have been using it in 2 clusters, and in the Barcelona Supercomputing Center, Mare Nostrum, and it works quite well. And so it doesn't crash at least. And the pipeline scripts are portable across multiple executions and can be shared and replicated easily, as we have tried and shared with other institutions. And what I want to emphasize is that Nextflow it's not a new language, so it's not polished but embellished Groovy and Java, but it acts more as a coordination layer for your pipeline task execution and nothing else. So it shouldn't be something too complicated. And in the future we are trying to develop some features in order to help bioinformaticians that they are not so used to this kind of to these frameworks, like this read evaluation console, in order to kind of be evaluate and test their syntax, and also a visual interface that we don't have yet. And as I have said, we are working on this in-memory computing grid, and we want to support also other data flow frameworks like Apache Start or Google Cloud. And now we are working also in Cluster K and Amazon Export instances, which should cut down the prices, because now in our institute just starting recently to charge us for computing, or more than before. So it should be really interesting. And so I would like to thank the organizers for giving me the opportunity to present here Nextflow, and also to some people that have made suggestions and contributions to improve Nextflow. And here you have the site, the webpage. There is a lot of documentations on it. And here is the GitHub repository with many examples. And here the emails from Pablo and from me, if you need to contact them. Thanks.
Thank you very much. I'm going to take this opportunity to end with a question in this. Have you tested any of the other pipeline tools that are listed on the tutorials? For example, bpipe?
Yes.
So could you in 30 seconds just compare how Nextflow compares to bpipe? Because to some extent,
compares in performance or just in taste?
Thinking in usage.
In usage, for me, what can I say? I prefer Nextflow, of course, but I think the main difference is the kind of approach or the paradigm that you are going to face. So Nextflow, it's more, I think, it's way more oriented towards a data flow programming paradigm than bpipe. And so it shows when you look at as I have showed you some examples of the diagram and the script, how it looks, you can see how there is this encapsulation and how are the processes and channels, the 2 main entities that represent the execution of your pipeline. And just by looking just these 2 elements, you can see how it's going to proceed the execution. So I think this is and apart from that, then you have minor details, whether this has some extra feature like Docker or whatsoever compared to others, but I think others have also some other features that we don't. So
we're looking forward to the tutorials.